Welcome back. I now show you how to work in Python to determine the internal rate of return and for our purpose the yield to maturity. We have seen how this works in Excel using the solver and using formulas in Excel. Now Excel is really great for many applications. However, Excel is not very straightforward if you work on more complex problems. In particular, it's very difficult to debug your Excel spreadsheet. You have to go through all of it and you have to check equations. Now it's much more easy to do this in Python. So let me just start. I opened Sublime. You can use any text editor or IDE you prefer. I added the folder to a project. This is entirely optional. We don't work with other files at the moment. And I just added a doc string at the top and make here a little statement. So this is for internal rate of return for bonds. Good. So what do we need and what do we want to do? So I think it would be helpful to start with a bond price that could be derived from your coupon rate, the maturity, and the par value, and an assumed yield to maturity or an assumed discount rate. So that's the first step that would be useful. So this is the same what you have seen in the formula in the Excel example. Let's start by defining a function. So I use the keyword def. I call this bond value, and then I put in a few arguments. We need definitely the coupon rate, so coupon. We need the maturity, and we need the par value, and we need a discount rate. I just already call this a yield to maturity, but you can also just take it as R or whatever you prefer. So that would be our function and our arguments. I finish that line with the colon. I do the indentation inside the block. I start with some doc strings just to say what the function is about. That's always useful to specify. And here basically I write down what these things really mean. Yeah, so the first thing would be to say, okay, the coupon I use is a coupon rate. And in our case it's almost always semi-annual. Yeah, so that's our standard approach, semi-annual payments. Of course, you could add an additional argument in your function to permit other forms of payments, so more high frequency payments, but these are very uncommon. But you could do that. Yeah, so that's up to you. We can always modify this later. Then we have the maturity. And the maturity would be in years. I just specify this in years. And par would refer to the par value. So it's just nice to know that. And yield to maturity is basically our discount rate. So it's yield to maturity. So here we are. So we specified what this function takes. We did not yet specify a return value because the return value here would be simply the price. Yeah? So we can say here returns the price. Yeah? So that's useful to do. Alright, now what we do is we just apply the formula and we write this down in an equation and just specify already our return value. So I use the keyword return, so this function will return something. And in here I go into the coupon, I divide by 2 because we have semi-annual payments, I multiply by our par value, so this gives me the interest payment, I divide by the interest rate, so it's divided by the interest rate. Again, we are here in a semi-annual setting, so I have to divide by 2. So I do this here, and then I multiply by the additional term which adjusts for maturity. So this is 1 minus 1 divided by 1 plus the discount rate. So this is 1 plus, just a bit of space to make it easier to read, your yield to maturity. Again, I have to divide by 2. So that will give me the discount rate, and then I have to put this to the power of the maturity times the interest payments per year. Maturity is of course in years. In Python, note this is power of. Yeah, it's not what you might be used to. That's not the case. In Python, double asterisk is power of. And then we add here the maturity times 2. So that should do it, and I have here the 2 brackets closing it all. That looks good. And then I have of course the additional term, which is simply my principal. So I get my par value back, and again I have the adjustment here for discounting up to maturity, because that's the last payment I obtain. So I can just simply take that and copy that part. Yeah, so that's my equation. Of course, if you look at this, this is a lot easier to debug than in the Excel spreadsheet, because in the Excel spreadsheet I have to go into each and every cell and have to make sure this is correct. Here I can easily apply this and modify it. Good. Now let's test our function. Let's call the function, and let's add a few things into it that could be used. There's one thing which is different from what we have seen before. I use here the coupon rate, but this is already in percentages, so that's maybe not ideal. So we could either modify it here and basically divide by 100. So we do this. That would address it. Or when we input the coupon, we do it already in percentage value. Yeah, so I would say that's up to you to decide what you prefer. Okay, let's put in our coupon. Just as an example, we just use the things we already have done because we know what comes out of it. So we have a coupon of 5. We have a maturity of 1 year. So this is our bond A in our previous example. We have a par value of 10,000. And we have a yield to maturity which we already calculated as 0.1152. Yeah. So that's it. Again, of course, if you want to use different conventions for yield to maturity, you have to adjust the formula accordingly. Yeah. So that's of course something where you have to make a design choice. Good. Let's call this function. I just call this the price. So this is what will be returned is equal to, and now I call the function bond value and pass in these positional arguments. Yeah, so that's when here the coupon, I can just actually copy paste that. This is why I use the same name, so I can just copy paste that in as positional arguments, and then I just want to print the price I obtain. Yeah, this should be 9,400 based on our example. I save that. I now execute. I'm in Sublime, so I execute this through the command line. So I go into the folder where I store the script. I click up here, type in cmd, and this brings me straight into the folder. And I'm in my command line. In, of course, a different setting. So if you work on a Mac OS, this is slightly different, but you will also be able to do exactly the same. So Python is my keyword. So to start with Python, IRR is the name.py. So I execute that file. Let's see. I might have done, of course, some silly mistakes. You never know. Let's execute that. And here we get our price, which is 9,400, and a few other things happening. So that's pretty good. So it's actually working. Yeah, so that's good to know. So it does work. We can of course now say, okay, we want to do some rounding here, but I just leave it for later. So that's the first part. Okay. Let's go back into this. Now we have a bond value. Of course, this is for a given yield to maturity. It does not give me the yield to maturity. So it might be useful to actually explore this a little bit further. So it might be good as a starting point to see actually what's the relationship between my yield to maturity and the price. Yeah, so we can just explore this relationship here. Yeah, or your discount rate in a more general term. To do this in a nice way, I think the easiest thing is to play around with different values of yield to maturity. So that's now the beauty here in Python. We can easily pass in, of course, a float, as we have done before, or we can pass in now an array. Yeah. So for instance, what I want to do is I want to have a whole range of values for different discount rates and see what's the price impact. Now to do this in an effective way, I now use the NumPy package. So I do an import statement NumPy as np, which is kind of a convention. So in here I just use np, I go into the NumPy library. I use linspace, so that's linear space. It has a start value, which I put very low to start with. It has a stop value, which I put quite high, so 15% in our case. And then it has a number of steps. Yeah, so I put in 100 steps. So basically what this tells Python to do is create yield to maturity starting from 0.01, go all the way up to 0.15 in 100 equally spaced steps. So this gives you basically a horizontal axis. So now what we can do is, just to illustrate this, we can just print our yield to maturity. Yeah? Also what you note is I simply reassigned yield to maturity. So it was a float here and it becomes a NumPy array later, which is perfectly fine in Python. We are dynamically typed. Yeah, that's perfectly fine. Good. Let's execute that and see what happens. And now you have exactly what you expected. We start here at 0.01. We go all the way up in 100 steps to 0.15. And Python decides about these steps in between. It's all equally spaced. Yeah. And you see this is inside an array. Yeah, it's nicely structured. And now we can, of course, work with that further. Good. So now what we do is we pass in this array into our bond price function. So if I basically just repeat this statement here and also the print function, we can do that. Just to check on this, I now mute this. I do a control and mute this. I just put in here, I think it's either control 1, but I work in so many different things. Let me just quickly check. I need to comment this out as control and plus. Okay, control and plus slash. Here we are. Good, so that's all done. I call the price function. Now the price itself should be also an array taking these different values into it. Let me just run this one more time and just check on that. I closed it, which was a bit silly. cmd. So Python internal rate of return.py. I'm running it, and now you see for different values of my discount rate, I have now different prices. Yeah. And of course it might be now nice and useful to actually see that happening. So to plot this as a function of the yield. For plotting, I use matplotlib.pyplot. That's a standard one to use. So I do another import statement here. So it's matplotlib.pyplot as plt. Of course, all the solutions, you have it available to you. So don't worry about typing anything right now. And what we do now is we simply do plt.plot. So we just plot this, and we use the yield and the price. So that's our x and y, so to speak. And I use plt show to make sure I actually see that when I execute. I can also, of course, name this plot, save it as a file, usually as a PNG file. And then I could, of course, import this into, say, Word or LaTeX or whatever. Yeah. Good. I run this one more time. Let me do that. I'm running it, and now you see the figure popping up, and you see there is a linear relationship between the two. It looks almost, it looks perfectly linear. So that's interesting. We are somewhere here, the 9400. So that tells me that if I start now looking for this yield to maturity, I can do a very simple algorithm where I start with a low value of yield to maturity and increase it slightly until I hit the point where I actually target my price. So that's the idea. Let's do that and see what happens. So I do another function here below, and I call this function find yield to maturity. So find yield to maturity, and again I pass in most of the things which we already have done before. So I just do a copy paste, except of course yield to maturity, we don't need that. So I do this, and we also need, of course, a price. So I put in the price, use the colon here, and I do another doc string just to say what this is about. Yeah, we can of course always add a few more things into it. So find your yield to maturity. So now actually what I do is I do an algorithm. So what you see in the Excel file using the solver, I replicate that now using a very simple algorithm. Again, we have to think about this, whether it works for all cases and so on. So we need to explore this a bit further. But now we are just getting started in Python, so it's good to start with a very simple, maybe a little bit flawed example. Okay, so I have a starting value of yield to maturity, which I put at 0.01. So I do some hard coding here. Then I use a while loop. So while loops execute while a statement is true. So the idea is I keep adding to my yield to maturity a tiny little bit and recalculate the bond value and compare this bond value to the price. So as long as the price, which will be initially of course different from my bond value, so as long as the price which I have given is less than the bond value, you keep adding, because the bond value initially will be definitely higher than the price. Then I increase my yield to maturity, which will reduce the bond value. And here inside this function I actually call the function we already defined. Yeah, so that's the idea. I call the function we already defined, and here of course I use the yield to maturity which I specify here as a starting value. And I finish this line with a colon. I do an indentation, go inside the block, and here I simply make the statement yield to maturity plus equal to 0.00001. So I increase it by a tiny little amount. The plus equal to basically means I start with the current value and I add another value. So this is a shortcut version of yield to maturity is equal to yield to maturity plus this additional markup. Yeah, so that's a shortcut version. Plus equal to is the same. What you see on line 45 is simply a reassignment of the value of yield to maturity. Yeah, so we do the shortcut version. It looks much nicer. Good. In the end, I might like to do some rounding, so I do a reassignment. I say yield to maturity is equal to rounding and yield to maturity, and I just do it to 4 decimal places. So that's nice. It looks better. Good. I could now do a print function here, so I can just do also a print to my terminal, I use a formatted string, so I put the F in front of quotation marks, so I can use a space holder to refer to my finding. So I can do the statement here, the yield, if I type properly, yield to maturity is, and then I use wavy brackets as a space holder and pass in the yield to maturity. Yeah, so I can do that. And here it has a return value, which is my yield to maturity. Yeah, so that's it, yield to maturity. Good. Okay, that is it. We have done all the stuff needed, and we now try to use it. So again, we try to call this function. So I specify here call function, and we just now try and see whether this is working. So the only difference here is we now ask for the price. I just will redo this because it's a bit more tidy. I don't have to do it, but just to make sure I don't, you know, by accident overwrite stuff. And I add here the price. We know the price is 9,400, and now we basically test this, and we call the function. I can also now assign you know, the yield to maturity to it, which is fine. I just call this function, so that's fine. Let's do that, and that will anyway print this to the terminal, so that should work as well. So I call the function, and now let's go back and execute that and see whether we made some mistakes. Let's run this through. It's doing that, and it's now running, and we get yield to maturity is exactly as expected, 11.52%. That's great. So now we in fact replicated in Python what we have seen in Excel. There are certain benefits. Number one benefit is this is an awful lot more tidy. I can scale this up. I can do this with thousands and hundreds and thousands of bonds. I can easily optimize and also change values as I wish. So that's an awful lot nicer than working in Excel. And of course I can always try to link these two different methods, which we will do later in the course. Good, I see you in the next one.